Welcome to today's webinar. It's a little refresher look at ryegrass and herbicide resistance with Peter Watsalis. So thank you for joining us, Peter. Just a couple little housekeeping things. Please throw questions into the question box on the side panel in the webinar screen. Once we get through Peter's presentation, we'll run through all those questions and get them answered, and unless Peter's covered them previously. Probably the last thing to do is just acknowledge that this is a VegNet funded activity, and this is funded through the vegetable levy through Hort Innovation. So we're delivering in partnership with AusVeg on behalf of Hort Innovation and vegetable levy payers in Tassie. So without too much further ado, I'll just hand over to you, Peter.
Thanks, Ozzy. Good afternoon, everyone. This is the 6th presentation in 6 days. And today I want to just go through some refreshers and some information on ryegrass herbicide resistance in Tasmania. Firstly, why are we talking about ryegrass and ryegrass mainly? Ryegrass is a very unique weed. One of its unique features is that it cross-pollinates, which means it accumulates resistance mechanisms from its neighbors. So plants that survive around individual plants that are resistant will accumulate the strength of resistance. So over time, if surviving plants are left over several seasons exposed to the same mode of action herbicide, that strength increases more and more. And we'll talk about some very high levels of resistance. Recently, I've actually confirmed some ryegrass, not from Tasmania, but from parts of the Yorke Peninsula in South Australia, resistant to 2 litres of clethodim. So that is 4 times the field rate. That doesn't happen overnight. You've got to work really hard to try and produce that kind of resistance. And that's where the DIMs have been used, plants have survived, they've cross-pollinated minor mechanisms in the same plants, and over time that increases and it leads to a reduction in weed control. So the photo on the right-hand side there just shows a pot of ryegrass seedlings, and one individual there is albino. That's just a visual example of genetic diversity. A ryegrass has lots of biochemical diverse features, and some of those happen to be herbicide resistance traits, and that's what the problem is. So it's very genetically diverse, and the slide there, the plot, shows the exact example. So there we've got a dose response of some populations to glyphosate. So survival on the x-axis, and glyphosate rate too. What we've done there is we've got a susceptible plant, and you can see that at field rates, it's controlled. Then we've got 2 ryegrass populations with resistance. One has a mechanism, and the other one has a different mechanism, just highlighted as mechanism 2. So when we take a plant from each of those populations that survive glyphosate, put them in a pot, allow them to cross-pollinate, and then take the seed from that hybrid seed and compare it back to the parent, so the susceptible, you can see there's been a shift to the right. That means that this particular hybrid is much more resistant than either of the parents. And when we take leaf tissue from this hybrid back to the lab, we can actually identify both of those mechanisms in the same plant, and that's the reason why the resistance has increased. And ryegrass develops resistance due to different mechanisms. So you can have metabolic resistance where the herbicide is degraded in the plant. So you spray the herbicide and it's chewed up by really actively transporters, and that really does the job. You've got sequestration, and that's common in ryegrass glyphosate resistance, where the herbicide is moved to the tips and you get sort of leaf tip burning, but the meristematic area at the base of the plant is protected. And that's also the same. We find that for paraquat-resistant ryegrass as well. The other mechanism, which I can't see, that's increased expression. So you've got the susceptible target enzyme. So you spray the plant, the herbicide binds to the target enzyme and kills the plant. But where you've got 50% more of it, there's so much more left over that the plant keeps the function. And as you increase the rate, you start to get better and better control. And the final one is target site resistance. And that is what's causing grief with the DIM and the FOP herbicides and the sulfonylureas. It's that particular mechanism where you've got a target site, and because you've got a mutation there, it causes a physical change in that binding pocket, just like a lock and a key. You change the lock, the key doesn't fit. Exactly the same, and therefore the herbicide does absolutely nothing. So they're the four ways, the four main ways actually, that ryegrass can develop resistance to various herbicides. This is the latest survey information that we've got from Tasmania. So this is the 2020 GRDC funded random weed survey, which focused around the central main cropping parts of Tasmania. And so we've got about 50, 60 samples, and they've tested with various herbicides. So just to summarize what we found that 86% of the ryegrass was resistant to the fops. So that the way we confirm resistance is we'll spray plants at the 2-3 leaf stage, and where we have 20% survival or greater, we call that a resistant population. And here we've got 86% of those populations were resistant. Clethodim 52, so virtually 1 in 2 paddocks were resistant to the dim herbicides, and that's much higher than in previous surveys, where the surveys have been much more extended to the northern and the western parts of Tasmania, where we've focused on the central cropping areas. The FOP and the dim resistance is much higher. IMIs, sulfonylurea is 71%. So I guess those guys might not be using too many sensitive rotational crops, so they can rely on the sulfonylureas and the IMIs. 16% of glyphosate, so it's becoming more common, and 15-16% is the average glyphosate resistance throughout the entire country. So some states have more. So Tassie's has the average for all the countries. And then to the pre-emergent herbicides, we've got trifluralin, Stomp, Oxagold, Secura. We even tested Overwatch and Luxamax. We didn't detect any resistance. So you can see which herbicides are not working in all cases and which ones are. It's classed as the post-emergent are failing and the pre-emergent herbicides are working with respect to efficacy. So let's look a bit more focused in some testing that was done last year with 14 to 15 samples. So these were collected as plants through RMCG and Ozveg. So from 14 paddocks during the growing season. So they were plants physically collected from field, sent to us in Adelaide, and we trimmed them, planted them in the pots, allowed them to regrow, and then sprayed them with herbicides in the spray cabinet. And what we found was virtually all of those except one showed significant levels of resistance to fusilade, representing the FOP herbicides. 100 RR means complete survival, 100% survival, and the plants that survived were really healthy. RR means there was a little bit of stunting, but not still significant. So yeah, lots of resistance to the FOPs. When we move across to Clethodim, we see the efficacy is much higher. So good control. So both fusilade and Clethodim actually have the same mode of action. However, the binding is slightly different. And so where we get the mutations that bind to the fusilade, Flasfop mutations, they're more common than the Clethodim ones. And that's why we've got much more resistance to the FOPs than Clethodim. See that in all cases, we did detect some resistance to Clethodim, 35-40% RR. That means that those plants were healthy and quite healthy. Whereas the 5R, they were plants that were really only 5% survived, and those survivors had lots of damage. So that's where crop competition could really help. So you see a big variation, and there's no correlation between the activity on fusilade and the activity on Clethodim. So you see some that were highly resistant to fusilade were really strongly affected by Clethodim, and some that had intermediate resistance to Clethodim also had intermediate resistance to fusilade. So the correlation is all over the place there. When we look at glyphosate, it was effective in most cases. However, there was the odd case where we had low level survival, and those individuals were heavily damaged, and thus we've given them the R rating. The 0S means zero survival, and S meaning susceptible. So in summary, lots of resistance to the FOPs, some resistance to Clethodim, but there are some opportunities there, and glyphosate just starting to creep in the vegetable growing areas. So clethodim is one of the most important herbicides in vegetable crops, if not the most important herbicides. So where I've obtained through my herbicide resistance testing, there's about 390, 400 cases where growers have requested for clethodim 500 mils to be tested, and also clethodim plus factor, so 2 DIMs together. So that's a legal way of increasing the DIM load in pulse crops. And what I've identified is that of those resistant to 500 mils of the old formulation of clethodim, 40% of those were killed with the clethodim factor mix. So even though they're resistant to clethodim, they were killed outright with that mix. 20% of them showed very strong damage to that mix of both DIMs, and 40% of them showed higher levels of resistance to that mix. So even they were resistant to clethodim, they also were resistant to clethodim plus factor. So you can see that sort of split, 40-20, 40 split kind of thing. So if you've got clethodim resistant ryegrass and you've never sprayed the mix and you want to take a chance, you've got a 40% chance it's going to kill it, and you've got a 60% chance there'll be some survival, and 40% chance that the plants will be almost as healthy as they were to surviving clethodim. So failure to clethodim is not always resistance, and there's many cases where we'll do a test and the result will be 0% survival, and the farm will say no, it's resistant to clethodim, and then when we analyze the conditions, we can identify what was the issue in the field, in the paddock. So spraying younger plants is a very effective way. So if you let them grow bigger, if they start to tiller, then the whole physiology of the plant changes. And so plants are much more tolerant at tillering stage than prior to tillering. If you're spraying earlier, it usually means you're spraying younger weeds, you're spraying under warmer conditions, less chance of frost, and better coverage. So clethodim is activated by warm temperatures. So as the temperature drops degree by degree, the efficacy drops as well. So in Tasmania, you've got cold conditions, you've got short day length in the middle of winter. They are features which do not favor clethodim efficacy at all. So that is a negative for clethodim to work better. Frosts are no good. That even reduces the efficacy even more. And coverage is also very important. So if you're not applying enough herbicide onto those plants, if you're driving too fast or your coverage is not optimized, then if you get a sublethal effect, then if the plants have got slight low level resistance, getting less on the leaves will exacerbate the actual efficacy even further. Furthermore, if the ryegrass is stressed due to any other factor like waterlogging, that'll reduce the efficacy as well, because clethodim is absorbed by active transporters, and if the plant isn't actively growing, then those transporters don't work and you get less product actually through the leaves. Using ammonium sulfate is very important. So adding ammonium sulfate first to condition the water. Even if you're using rainwater, it's still very important to add ammonium sulfate, because ammonium sulfate not only conditions the water, but it also helps the activity of clethodim through the plant. And also using good quality products. So there's hundreds, probably over 100 clethodim products. I would stick to the ones from reputable companies, because the ones that are cheaper to buy are usually lower quality, because they have less good quality dissolving agents to make that product up. And using good quality oils as well. So things like hasten and uptake, buying adjuvants from reputable companies as well, and keeping that rate required for the particular crop you're actually targeting for. So here's some examples. Here we've got on the back 3 pots, we've applied glyphosate over all 6 pots. You've got survival on the left-hand side, and less survival in the middle, or no survival in the middle, and a little bit on the right-hand side. So the back row is where we used double distilled water. The front row is where we used hard water, 312 parts per million. It's not overly hard, but it's sort of an intermediate hardness. So the first thing you can see on the left-hand side, both those pots, there is survival. So even in soft water, there's still survival. But when we add ammonium sulfate, we get complete control, not only in the hard water, but also in the soft water. So it shows that apart from conditioning, ammonium sulfate is doing something else to make glyphosate work a lot better. And on the right-hand side, adding wetter also helps as well. The plots on the right-hand side there, you can see the effect of glyphosate and the effect of glyphosate plus ammonium sulfate. So you can have quite a significant effect by adding ammonium sulfate, by adding it carefully, the right concentration, and letting it mix into the tank, and then adding the other components afterwards. This is the efficacy of frost. So there's two independent studies here. Those plots are from 2 years of data by a PhD Sheridan, and one of her projects was to investigate the effect of frost. So she grew plants in a frost chamber, dim-resistant ryegrass in a frost chamber, and then exposed them. So she put the frost before the application, after clethodim application, and also had plants not growing in the frost conditions. And what she found is that when she applied the frost before, the plants were much more tolerant. Now that's the red line there. So you can see that there's a significant difference with of those plants. Whereas the blue and the red lines, well, the blue line is where there was frost after, so they applied clethodim, and then the frost was after the clethodim application. So I put out the clethodim, and then the frost came. We got much better results, very close, if not significantly different, to not exposing the plants to frost at all. So that is a very significant one. We then decided to try and verify this by growing plants and taking a subset of those plants to a location in the Adelaide Hills in winter, in July in 2020, which is high risk of frost. It's called Frosty Flat. So they don't call it Frosty Flat for nothing. And we took the plants there, we exposed them for 3 days at about -1 to -3 degrees, then brought those plants back, sprayed them with clethodim, and sprayed plants also that were growing outside in Adelaide, but not exposed to frost. We then, after spraying, took a subset of the plants that hadn't been exposed to frost back to Frosty Flat location and left them there for another 3 weeks, exposed them to more frost, then brought them back and assessed. And what we found was exactly the same as the information that the PhD Sheridan had found, that spraying clethodim before frost, you get much better control than waiting after a frost. If you've had a frost, depending on what the recovery and the temperature time is afterwards, you need a couple of days at least for the plants to start to recover before you can apply clethodim, because sometimes it may not be practical to spray it before. So 2 sets of independent trials showing the same result. There's very limited herbicides in vegetable crops. Apart from clethodim, there's very few others that are really strongly effective on ryegrass. So targeting ryegrass in other crops where there are a lot of options, many more options, is really the way to do it. So try and reduce your seed bank. So when it comes time to the vegetable crop, you've actually got a lot less seed in there to compete with the crop. And that includes really hitting hard non-herbicide techniques like as hay or silage. So removing the ryegrass from the paddock completely, so you don't get any seed set for that particular year. There's a lot of differences between Tasmania and the cropping over this way, and one is the actual distribution of weed seeds. But that's one of the main ones. Another one is rainfall and irrigation, and that can actually work well your way because you can control if you have more irrigation, more rainfall, more regular rainfall, you can get better control with pre-emergent herbicides. You have to observe which products you can use because some may have residual effects for the following crops. Because some of those paddocks are tilled, then the herbicides or the weed seeds are distributed much deeper than in where you're not cultivating at all. And so in no-till systems, the weed seeds are right close to the surface, whereas if you're cultivating the soil, you're introducing tillage, then they're spread right through. So if you're using a herbicide that's not very water soluble and you've got weed seeds growing underneath it, then that herbicide may have reduced efficacy. Also, some of the herbicides will bind to organic matter. So if you've got a lot of crop residue, if you can't see the ground, then you have to try and imagine how's that herbicide going to wash off the stubble into the soil at all. So that's also another issue. And but you can get away with higher rates because you've got heavier soils as well. So using the higher label rates, some products. So this is a summary of the main herbicides that are available in Southern Australia. So you've got things like carbidamide, Ultra, which is registered in pulse crops. It's got quite low, it's very soluble, so it'll move it through the profile. So if weed seeds are buried a little bit deeper, then this will wash through to them and have good damage. And also the binding to organic matter is pretty good. S-metolachlor, Endure Gold and Boxer Gold, that's also got very high water solubility, so that'll move down. And the KOC is the binding. I just move this across because I can't see that. Yep, that's right. So there's the binding. So we've got medium binding to stubble. And that means that with rainfall, you can wash a lot of that herbicide off the stubble. Metazoclor or Tenet is also highly soluble and low binding, so it'll move off stubble very easily as well. Luxamax or Synmethyline, again, very good features, medium binding and medium solubility. So you see a lot of the products have actually got medium to low or medium to high solubility. Things that are low soluble, you need a lot of moisture, a lot of energy of the rainfall to wash it into the actual soil level where it's going to cause some damage. And where things are binding, then it's also going to create some issues too. Things like trophyllin, which due to poppies, it's not very common at all, or stump will be very similar. So pendimethalin stump, it's got very low solubility, so it won't dissolve in water at all. And it's got very high binding, so it sticks to stubble and it doesn't wash off at all. So using that in Tasmania can be an issue if you've got those particular features. But there's a lot of variation there to try and get those work. These are the herbicides that will control the resistance to glyphosate, fusilade, clethodim, and to any other post-emergent mode of action. So somehow there has to be a fit to choose herbicides that are going to work in a particular system so they can control the ryegrass. So knowing which herbicides will work and which herbicides don't work is one of those very important features. So you're not wasting money buying herbicides that don't work, and you're not infesting your crop by having blowouts of ryegrass. So using herbicides that do work. So resistance isn't everywhere, and you saw in that table I showed you of the fusilade, high levels of fusilade resistance, but very low levels of clethodim resistance. Some of those were complacent clethodim, but what we were able to show is that the actual level of resistance to clethodim is very low, which indicates there are other factors causing the reduced control. And so thinking about what may have gone wrong can optimize the efficacy for next time. So the main testing there, we have two ways of testing for herbicide resistance. One is weed seeds, and we're conducting those at the moment. And the second one is plants. So they're plants that are growing in the paddock either before herbicide has been applied or after herbicide has been applied. And we can send that over, we can trim it back, plant it into pots, and spray with herbicides and get a good idea what the situation is there. So here's a situation where we've got, a dose response with herbicides. So it only takes takes about 4 weeks with a quick test. So it's quite clean. And I'm trying to see the labels there. We've got some clethodim resistance in the middle there and some other resistance on the right-hand side. There's a table here which comes from a typical report, and that one there they've used Verdict, FOP, and they've got 70% survival, clethodim 250 mil rate, so that's the low rate. There's 20% survival for increasing to 500 mils. It's given complete control, so 0% survival, lots of resistance to sulfonylureas, but no resistance to Intervix, which is the same mode of action, but you get these differences between chemical families. So that's why testing allows you to identify those subtle differences, which may be opportunistic in a particular paddock, but not in a neighboring paddock. In glyphosate, there's a little bit of resistance there, but nothing to pendimethalin. So the photo below the table just shows you that a litre of glyphosate, there was a lot of resistance, but increasing it to 1.5 litres, we got complete control. So there's the starting of weak resistance. But there are some features. The other photo there shows you that the front row, susceptible ryegrass is controlled. The ryegrass in the back is from another paddock. Shows you that even at 4 litres a hectare, we've still got plants surviving, very healthy. So you need to identify where you are in the sensitivity range. So just to summarize that, ryegrass from 14 vegetable crops exhibited really strong resistance in fops, such as fusilade, but a lot less resistance to clethodim. Now, in those situations where you've got low levels of resistance to clethodim, or any resistance really, like I mentioned right at the beginning, if you allow those to cross-pollinate and set seed, those individuals will have high levels of resistance than the plants out in the paddock there. So the idea there is to try and minimize that effect, to try and stop that resistance from increasing to some crazy levels that I've identified over here in South Australia. Clethodim and factor can be effective on clethodim-resistant ryegrass. So there are crops that you can grow in Tasmania, pulse crops. I think even linseed could be as well, could be very effective to control ryegrass. So to kill ryegrass with that higher that higher double mixture. Herbicide resistance identifies the what levels of resistance you have, which herbicides work, which herbicides don't work, and that way you can really focus in using effective strategies only. And using pre-emergent herbicides have completely different modes of action. Try and optimize those to work for your particular situation will be a way forward to try and reduce the numbers of ryegrass in the non-vegetable phase, which then makes, if you reduce the seed bank, you get much easier levels to control in the vegetable phase. And I'll leave it there, Ozzy. Hopefully you were hearing me.
Yeah, all good. Thank you, Peter. Thanks for all that. And yeah, just picking up on that point that with our testing last season, that there was considerable overestimation of how resistant paddocks were going to be to clethodim. I think every grower that we spoke with thought that they were basically clethodim resistant paddocks all the way through, and there was a lot less resistance than expected. So yeah, we've had some questions coming through, so keep them coming, everybody. We've been a little dry down here. The autumn break rain isn't quite on the horizon. What's the best tactics around managing staggered ryegrass emergence? And also throwing in there, is there a case for a potential tickle cultivation to get some ryegrass germination in a paddock ahead of another crop coming in?
So what are the main crops going in? That's the key feature.
Yeah, well, I guess onions will be the main, that would be the earliest crops going in.
Okay. Yep. So talking about absolutely. If there's a little bit of moisture there, if there's enough to get some of that seed to germinate, then yeah, absolutely getting a control early on with glyphosate at the 2-3 leaf stage is very important. One thing I didn't mention is if the ryegrass is at the 1 leaf stage, glyphosates can be very ineffective because all of the energy is going still from that little seed to the shoot. So it's only after that ryegrass enters the 2 leaf stage, that's where the ryegrass is really starting to photosynthesize and there's energy heading towards the roots to start creating roots. So if you come too early, reduced effect. But paraquat does work at that 1 leaf stage. So yep, using either glyphosate or paraquat early tickle is a very good strategy to get ryegrass up. Absolutely.
Yep. No worries. So I guess in terms of when we have resistant populations, what's the strategies to start to look at?
Okay. Well,
you touched on a couple, but yeah.
Yep. No, a lot of guys here, what they're doing is for many years they've been doing the double knock, and that is where you apply glyphosate, and then within 5 to 6 days, or within a week, but the sooner the better, applying paraquat. And what happens is that you apply glyphosate. Glyphosate's very slow acting. And so if you leave it too long, so if you spray glyphosate, say in 12 days, the plants that are glyphosate resistant, or the plants that are susceptible are going to die. The plants that are glyphosate resistant, they start to stress, but it takes a long time to stress. So if you're applying paraquat on stressed ryegrass plants, and here the stress is not frost, it's not nutrition, it's actually the glyphosate, then you can have reduced control. Whereas if you apply the paraquat within sort of 5 to 7 days, you can hit those plants and kill them before they start to stress from glyphosate. So a lot of farmers have used this strategy very effectively, but some of the farmers that are getting a lot of glyphosate resistance are relying only on paraquats. They're getting paraquat followed by paraquat, and there are about 50 cases currently over this way, which the ryegrass is resistant not only to glyphosate, but also resistant to paraquat in broad acre situations. But what I would suggest for now, chicle, glyphosate, and within 5 days, paraquat, especially if you've done a test and you know you've got some glyphosate resistance in that paddock, follow it up with paraquat so you can stop the glyphosate resistance from increasing further.
Excellent. So doubling back a bit with that water solubility and clinging onto the stubbles and so on, would using a preem with a higher water solubility, would that be useful for targeting deeper ryegrass seed?
High water volumes? Yeah, that does help. Yep. Absolutely.
Yep. So you're getting that right down. Does high organic carbon levels in soil, is that a similar effect to organic matter, like stubble?
Yep.
Or once it's broken down, it's not as...
Oh no, it does bind, not as strongly as stubble, but yeah, it does. Any organic matter that does bind a bit stronger. Yes. So binding doesn't mean complete ineffectiveness, because even on stubble, if you then drop that stubble when you're sowing, so you've got that stubble in the ground next to the seed, then any seed that's close to the stubble will actually die. So even though it's connected to the stubble, it's so close that when the roots start to grow, right in that vicinity of where the stubble containing the trifloran, for example, is, it'll start to kill it. It'll do damage. It just doesn't move. So if it's a water-soluble product, it won't wash and disperse from the stubble into wider areas away from the stubble. But right next to it, yeah, you still get efficacy.
Yeah, beautiful. Question here is, in terms of this is with your robust data, Peter, that you've got from around the country, with your data on tolerance and thresholds, do you feel there's a responsibility for the APVMA and chem companies to acknowledge that data and amend current label rates?
Yeah. So the way that
labels. Yeah.
Yeah. So the way clethodim, the rate on the clethodim label, I believe, starts from 125 mils of the EC240 to 5, and it used to go to 250 mils. That was about 15 years ago. That was the top label rate was 750 mils because it worked so well. There was hardly any resistance. Now with problems, there was enough evidence to show that if you increase it to 500 mils, growers were doing it for 10 years before then anyway, you let off label. So, but what they found that increased the rate, and ryegrass control was amazing with 500 mils. And the efficacy work was done and showed that no residues were identified in the seed. At higher rates, hasn't been tested. The issue now is who's going to do it, because back then, I think clethodim was still in patent, so the company it was in their interest to actually to register it, because it means you can sell more clethodim. But now where you've got probably over 100 clethodims, getting any private company to individually do it is going to be very difficult, but there may be opportunities to use higher rates. And because if you don't find it in the seed, then happy days, you can still use it. But we haven't got any maximum residue levels, any MRLs for higher rates. That's the issue there. But there may be a biological opportunity to do that.
Okay, so it comes down to the funding. There's no commercial incentive for chem companies to go with that. And
exactly.
Even though your data does show tolerance at higher levels, that's not sufficient to cover the analysis that the APVMA would need to see to boost that.
Who would physically do the work, and who would physically do that to get clethodim, the mix combined? Even using higher rates of clethodim at a litre per hectare, you can still get quite significant improvements or complete control. Just like I showed with the glyphosate, at 1 litre you had survival, at 1.5 litres you didn't. There are many cases with just using clethodim that if you increase the rate above that 500 mil rate, you get complete control of the ryegrass.
If I could just interject there for a minute as well, the minor use permits that permit higher use rates of clethodim do exist for certain crops. APVMA has been going through the process of converting minor use permits to registrations without necessarily requiring the whole breadth of data. So that might be a pathway there as well. I'm not sure if they're still running that program. I think it's come to an end, but there was a period of time, I think the last 5 years, where they've been putting minor use permits into registrations because they would prefer to have them on label. So if you have a minor use permit for a double rate, for example, in a particular crop where it is required, that might be a pathway to go down.
Okay. Thanks, Naomi.
Yep. And just to refer back to it, we recently hosted our webinar on minor use permits with Peter Del Santo. So if you've got questions about applying for and using minor use permits, jump onto the Tas Farming Futures website and have a look at our recording from that. That'll provide you with a lot more detail, or get in touch with me by email. I can supply the right web address to go to. Peter, with one of the next questions here is about burying seed and sort of that being a negative thing here, that seed's getting a bit more buried. I guess anecdotally we've heard before that with our heavy wet soils here in Tas, deep burying seed can be an effective control measure. Do you have any comments to throw into that?
Yeah, if you're leaving it at depth, then yes, it can be. But if you're bringing it up with every cultivation system, then you're re-exposing it, and that usually just triggers explosions in germination. So if you can bury it deep, yeah, I'd say 15 centimeters and below, because around that 10-ish centimeters, some of it can get through. But if you can bury it below 10 centimeters and leave it there 5 years plus, then yeah, you can start to reduce its efficacy because you've got moisture at that level. So you've got biological activity, albeit it's slow because it's cold, but it's still that moisture will enhance microbes to break it down. But if you're burying it deep and then a year or two later you're bringing it back up, you're not really doing any damage. So over here, some growers are very, very few, but some they'll multiple plow a paddock very carefully and just bury that 20 centimeters deep and just leave it there for 10, 15 years, or probably never do it again. And they've just buried that, kind of reset the clock, and then they're quite careful with what they do thereafter.
Yeah, excellent. I guess too, we've just got a question here with the allele, and I may butcher this, but the allelopathic effect of certain cover crops like soya oats, that's useful in suppressing ryegrass germination. But is there any winter cover crop options you know of that are useful?
Well, if you can, like get a mulch kind of setting, then that will definitely suppress ryegrass. So yeah, anything that'll block the top few centimeters, that'll suppress ryegrass. Ryegrass likes light and likes to be exposed, but if you're mulching it, cover cropping it over, then yeah, that can have a huge effect as well. Absolutely. Certain weeds not, but the ryegrass it's a very small seed, so it doesn't have a lot of energy, so it can't really punch through there. So if it's germinating on the surface, below the surface or at depth, then trying to get through another layer of something on the surface, that's going to make it very difficult, and there'll be a lot of suppression. That's the physical barrier. If your cover crop's got other allelopathic residues and other stuff, then yeah, that can also help as well.
Excellent.
Another thing I didn't mention, and I don't know if anyone's doing it, especially some of the more broadacre type guys that may have vegetables in their rotation, is crop topping. So in crops like barley, if there's a big difference between the the flowering of the ryegrass and the crop, you may be able to use one of the glyphosate to sterilize the seed if the crop has passed a certain maturity stage. I'm just not too sure how the phenology works in Tassie with the ryegrass and the crop. I mean, here in this part of the world, sometimes it's opportunistic, especially if it's a dry finish to the season, and that ryegrass is really powering on to try and mature. So it'll start flowering well before the crop. So if the crop's past a certain stage, then you can safely apply glyphosate because the crop is also quite mature, but the ryegrass is still flowering. You can really do some damage. But I just don't know if anyone's done any work in Tassie with crop topping, if any of the crops. It really depends on the phenology.
I've not heard of that being done here. Naomi, do you have anyone?
No, and Desiccation seems to be probably the big opportunity for us, but I guess the issue is our long wet springs, the long wet, sort of good mild springs that we get here. Means that ryegrass often flowers early and late, so the staggered germinations as well, we sort of don't have very clear cut seasons in that respect. So I'm not aware of work being done with that. There might be an opportunity with desiccation in barley, but again, probably not hitting a ryegrass at the right time there.
Yeah, once the embryo starts to get into that hard dough stage, then it's mature.
Beautiful. So some more bit of a follow up from our burial points we just had. So what's the time frame on ryegrass seed viability?
It really depends, but a lot of studies have been done and shown that if you could stop seed set for 2 years, sometimes 3 years, you can crash the ryegrass to minuscule levels. So in no-till, it's about 2 years, sometimes 3 if you start with a really, really big seed. So if you start with 50,000 seeds a square meter, you're going to need about 3 years to reduce it right down. But if you're insulating it with soil, it might be a bit longer. But then if you're exposing it to moisture, that can also break down the degradation. So I would say about 2 to 3 years, you get rid of most of it, assuming you don't have any ryegrass that's germinating in that and setting seed, or you're not introducing ryegrass in from another source. So from a crop seed that hasn't been cleaned properly, or even through machinery and other forms of hygiene into that paddock.
Excellent. And then a question here: Does fumigation work on small patches of resistant ryegrass? Be used?
Sure. Yeah. If you use those fumigants, absolutely.
And then, what do you think is the role of biofumigation? Have you seen that utilised or done much looking into that?
No, I can't really comment on that.
No worries.
But if it controls other weeds, then ryegrass is quite a thin seed, so it hasn't got a hard seed coat like wild radish has, for example. So I would assume if that system is controlling other weeds, then it'll probably work on ryegrass as well.
Yeah, excellent. So I think there's a couple of questions here with around frost, and I think we talked about. You mentioned at least a couple of days after frost before you apply clethodim in those instances. Just touching on what's the marker for frost? Is there an air temperature level below that, or is it soil temp, or is it a bit of mixture of both that we need to be considering?
Yeah, sure. No, it would be the air temperature. So it has to. That's where that's affecting the plants more than the soil temperature. And it doesn't have to be a frost. It just has to be cold, and then the efficacy just drops incredibly.
So on that, below what temperature does the efficacy really drop? So for us, we often get at the right clethodim spraying window multiple nights in a row of 3, 4, 5, 4, 3 degrees minimum temperatures, and that's air temperature, not ground temperature where the plants are. So what's the real threshold there in minimum overnight temperatures that we're looking at?
Those temperatures are really cold. Efficacy is going to just drop off. So what I don't know is that if you're using a higher rate, whether that equates to an activity of half a litre under more warmer conditions. So you might be able to get away with a higher rate, and that's why doing some of this work with getting these minor permits is really important, because what you're trying to do is kind of get an activity of clethodim around that sort of 12 degree mark. That's where you get lot better control. But when you're around that 3-4 degrees, that's really cold for cleth. It'll work, but really slowly, and that's just one of the factors that negates the final activity of the product, because you'll get uptake. You just get very, very slow translocation, like movement to the growing point, and so the plants is starting to grow, and that clethodim is getting to that growing tip so slowly that it's actually growing at a faster rate than the clethodim is actually doing the job. So that's why you get that reduced control. Whereas under warmer conditions, that clethodim rapidly moves and just floods that meristematic region at the base of the plant, and that's why it works so fast, so well.
Excellent.
So sorry, I
Nice.
can't do anything about the temperatures in Tasmania, but if you get a warmer, you get a lot better results.
Just build big greenhouses everywhere.
Yeah, that's right. But glyphosate on the other side works really well under cold conditions. Problem is you can't spray glyphosate over onions.
Yeah. So just following on a bit further with that. So how many generations do you think it is, or have you done the work around going from a 1R resistant plant to a triple R resistant sort of level that you'd see? How many generations would that usually take?
It really depends what the starting genetics are. So so I didn't show it, but there's 7 regions, genetic regions on that binding pocket. So the enzyme is called ACCase, and then a very small part of it is the binding site. On that binding site, there are 7 physical regions where if a mutation occurs, causes FOP and DIM resistance. And then at each of those regions, you can then have different mutations. So you've got another layer. So not only is it decided by which of the 7 or 8 mutations, but also what mutation occurs at each one. And then if you start to accumulate those in plants, it just skyrockets, becomes massive. So if you were spraying clethodim and getting, a sort of a 60, 70, 80% job, and the ones surviving, they cross-pollinated, and that happened for the next 3 years, you'll lose clethodim rapidly. So I'd say about 3 years, and it's over. If you haven't got any other processes in there to stop that generation or reduce it significantly, that's where it skyrockets. And the growers over here, any growers that are using any of those late season tactics, crop topping is really popular in pulse crops. So you can use paraquat in pulse crops, and that's where you can really sterilize the seed. Paraquat works instantly, so it instantly sterilizes the ryegrass seed, and the actual pulses are very thick walled, the seeds or the seed walls, and so you don't get any going into the actual seed. So the pods are really thick walled. So that could be an opportunity there. The pulse crops, phenols great pulse crops. So peas, which you are growing, but yeah, they're fresh peas. They're not the dry peas. Also faba beans, very tolerant. So a lot of growers are using that, and crashing populations. I've got data showing that you go from 10,000 plants a square meter to like 500 the next year, because you've just destroyed that entire cohort. That year's ryegrass has all been sterilized, so you can crash it down. So maybe there may be some opportunities with the pulse crops more than with the cereals.
I have a quick question, a pragmatic question. We've talked about growth stages, ideal growth stages for spraying clethodim on ryegrass in unideal conditions. Again, coming back to our long germination window and multiple germinations, it's really hard to get a consistent growth stage across our paddocks here. Say you're going to do a scout, how would you look at the plants and how would you estimate the right growth stage in any given population of a paddock, and say, I don't know, 5-6, an average 5-6 leaf growth stage would be the best time to spray? What would you do there?
Yeah, so I would, the issue in onions anyway is that they're not very competitive. So you're actually, even if you can get a good kill early on, you can't get a canopy closure, so to speak, to actually suppress any more going forward. So, and also from what I'm aware, that onions are sort of not that tolerant of too much clethodim. So your half a litre rate is about the maximum you can put, and even then you have to sort of watch which oils you're using and also what concentration as well. So that also affects it too, because things like 1% Hasten really are a lot better in getting that through, because clethodim is a EC, so it's an oily, and if you're putting an oil on the leaf surface like the adjuvant, that's helping the clethodim get through. But if the Hasten is damaging the onions, then and you use other ones which have got that high concentration, then you can have reduced effect. So Naomi, you basically got to take each paddock as it comes, and if they're susceptible, they'll be killed at greater growth stages. It's just that if you're starting to develop resistance, then the growth stage will kill them. And we have done a trial where we screened how many was it? A couple hundred ryegrass populations in winter at the 3-leaf stage and at the 2-tiller stage. And what we found, that we got 35% more of those populations were killed at the younger growth stage, which means that some of those which were killed at the younger growth stage had just enough genetics there to get them to survive, actually, albeit if they were damaged, they still survived and were able to set seed as young as you can, but as practical as well. And thinking about the temperatures and all the other factors, or you try to make that clindom as active as possible. And so that is with your water quality, using the right selective oils in there, keeping the rate up, the growth stage, the temperature, looking at all these factors and trying to create the best opportunity for that growth stage, and being able also to drive into the paddock if it's muddy and you can't drive in, well, there's another factor as well.
Excellent. Cool. Well, thank you, Peter. We're right on 4 o'clock now, so I'll if there's any final questions, please punch them in as quick as you can into the box so we can cover them off very quickly. If not, I'll just give a little plug to say to keep in mind that resistance testing and how critical that is in actually knowing what you're dealing with. Certainly, we had some surprising results from our survey last year. And feel free to get in touch with us. If you're looking at resistance testing, we'd love to give you a hand and assessing what to do, and making sure we're getting the right thing through to Peter for him to test. So with that, I have no more questions come through. So with that, we'll wrap it all up. Thank you very much, Peter, and thanks to everybody for attending.
No.
Thanks for your benefit of all that accrued wisdom. It's fantastic, and I look forward to having you back in the state one day sometime soon to do some work and go around. Excellent. Well, thank you, everybody. We'll leave it there. Have a good afternoon.
Thank you.